Hello everyone, welcome to Mastering Project Plan. Today's video, I'm going to tell about what is productivity. You might all have heard about this term in your projects. So, what is productivity means? So, productivity you can consider like what is the quantity output by a crew working on a single day, or else we can also put like the quantity achieved per day with that crew, or we may also consider like man hours per quantity, like man hours per ton or man hours per inch area. So in planning term, so productivity, it is kind of a rate at which the resource like your fabricators or your welders or your equipments like crane or anything, so that converts effort into a completed work. So this can be termed as your inch dia per day. So all you know, like inch dia is nothing but if you're going to do some pipe welding, like if you're going to weld the 8-inch pipe to 8-inch elbow, so then the one weld joint we call as like 8-inch dia. So this we can tell like inch dia per day, or suppose you're going to do a spool erection. So this all pipe to elbow or pipe to weld like flanges, we call it as like a spools. So that also we can tell like number of spools erected per day, or if it is for a concrete works, we call it like cubic meter per day, how much concrete pouring is done on that particular day. If you're going for a structural erection, then we call it as like tons erected per day. So then we may also call this like man hours per inch area or man hours per ton. So let us take one practical example where we are going to do some pipe spool fabrication for one of the oil and gas projects. So we are assuming like we need one welder and one helper to perform the welding. We will also assume like the crew is working on a 10-hour shift. So there, if they are working on 10 hours, they're able to weld 20-inch dia per day. So then means the productivity of the crew is equal to 20-inch dia per day. So suppose we want to measure in terms of man hours, why we are going for man hours. So this might be useful when you're going for some costing calculation, like how much money we are going to spend for performing that welding and how much revenue we have generated. So suppose we are going to calculate on man hours, then it will be like two persons, like one welder and one helper. They are working 10 hours. It will be 20 hours. How much shop welding they are going to achieve? It's like 20 inch here. So then means the productivity is equal to total man hours per like quantity achieved by the crew on that day. So it will be like 20 divided by 20. So we are getting one man hour per inch there. So what does it mean? So we are need at least one man hours to perform the 1 inch day welding. So this is very much important. Why, in order to estimate the manpower required to perform the work, we may also have some particular schedule. So then this is very much useful for estimating the manpower for completing the works on a particular schedule. Same, we may take example for a pipe shop fabrication fit up. So here the pipe with the elbow before welding, it has to be fit up has to be done. So fit up is nothing but a kind of a tag weld. So it has to be tag welded on various points so that the pipe and elbow does not move during the welding operations, or the alignment does not get changed. So for that also we may need the fabrication crew. So one fit up crew may have one fabricator and one helper. So let us assume like for some small project we need to do the shop fabrication of 2600 inch dia. So this has to be completed in a 1 month duration. So if it is a 1 month, so let us assume like we have 26 working days. So if we want to achieve this 26 days, we need to achieve this 2600 inch dia. So we may need to achieve the daily fit up quantity achieved by a fit up crew is like a 50-inch dia, right? Then so if you want to complete this in 26 days, that means like one day you need to have the fit up quantity as 2600 divided by 26 is equal to 100-inch dia. So that means so 100 divided by 50 will give you two fit up crews. So the fit up crew we need two, fabricators and two helpers. This fit up daily production quantity will be varying depending on the pipe size. So if you're going for the smaller pipe size, then maybe this may come down. Or if the pipe schedule thickness is very high, then also you are this in the welding you may have less productivity. So let us now come to pipe shop fabrication for welding. So let us assume like we may need to do 2600 inch shop welding on a particular month. So 2600 by 26 is equal to 100 inch area. So now one welding crew can do 20 inch area per day. So then your total welding crew requirement will be 100 inch area divided by 20. So that means we need 5 welding crew. So this means that we need 5 welders and 5 helpers which are required to complete the welding in 1 month. So for this crew also you may need some kind of welding supervisor or foreman to arrange the welding consumables and other mobilization of the welding machines and other things like he will be coordinating with the fabrication foreman to identify the welding joints for the welders. So we may also need to have the welding supervisor, and he may also check how the welding is performed by the welder, whether the is having the welding is performed in a proper way, like the root there is no any quality defects which is coming on the later stage, like there should not be no porosity, or there should be the weld, the metal has to weld penetration also has to be well. So this everything will be checked by the welding supervisor. Then there is also another term called work front. So work front is nothing but the quantity which is readily available to the crew to perform their works. Like for in this case, the like we may call it as like for the fit up and welding works, how much quantity is readily available to the crew. So suppose for the fit up crew, what does the work front means is like availability of the materials like your pipes, elbows or flanges or T's, welderlets to perform the fit up operation. Then the drawing also has to be in the IFC stage, so it has to be approved and it should be in the like issued for construction purpose. Then for this also we may do like spool gen, like weld map drawings. Like we'll be in the isometric drawing, we'll be putting some weld joint numbers. If it is a fillet weld, there will be separate tag numbers we will use. Like sometimes there are some support welds like reinforcing pad to be welded in the pipe, so then the joint numbering will be different. So in one of our earlier project we use like T1 T2 something, or you may also call the reinforcement pad is coming like RP1 or 2. Then the normal weld joints, like they consider like for the shop joint, we had like it will be of a circular type. Then the field joints, they had a different symbol for the field joint, so that it was like there are various symbols they use in order to identify which is shop joint and which is weld joint. So then so as you know, like over front is nothing but the quantity available. So suppose if there is some materials are not available, like your weld flange is not available or your elbows are not available, then you may not able to perform the pipe to the fitting welding. So that goes into the hold quantity. So we call like hold quantity due to non-availability of materials. Let us assume like 400 inch area. So in that case, the team will have only 2200 inch area of the work front. So this also we need to monitor like how much work front the crew is having. It has to be ensured that the work front, sufficient work front is available for the fit up crew or the welding crew, or else you may need to uh, reduce your manpower, or you may need to shift the manpower to other works like support fabrication works or some other works. So similar for the welding work front. For the welding work front is nothing but the spools has to be fit up has to be completed, and the fit up inspection has to be done by the client QC or the contractor QC. Then this fit up will go into like a welding work front. So the for the welding work front, so how much fit up is done, so that will be kind of a work front to the welding operation. So it is very good to maintain at least 2 to 3 days of work front for the welders, so that they have the continuous welding works. Hope you all understood about this productivity work front in this video. So if you found this video useful, please like, share, and subscribe mastering project planning, where we will be covering a lot of videos about APC projects and the construction or related to engineering works. Thank you for watching. See you soon in another video.